Today's lesson is section 4.2, day 2, so it's a continuation of yesterday's lesson because it's all about factoring. So I did go over this a little bit with you yesterday. We're primarily going to look at factoring trinomials today. So they have the form ax squared plus bx plus c. Okay, and we talked about all the different methods yesterday. Some of you use slip, slide, divide. Some of you may use California method or factoring by grouping or maybe even a different method. And feel free to factor using any of those methods that you were taught previously. I'm going to go over factoring by grouping and California method today. But like I said, feel free to use any method that you're comfortable with. Before we start to factor by grouping, just like I said yesterday, you have to make sure you factor out any common factor first. Okay, always look at that. It might make your numbers a little bit smaller, make the problem easier for you. Then you have to ask yourself the same two questions, and this is regardless of the method that you choose to factor. So you have to find two numbers whose sum is equal to the middle coefficient and whose product is the product of the first and the last coefficients. Okay, so that's where if you do slip, slide, divide, that's where you're doing the slipping and sliding. You're multiplying the first and the last together. All right, so here are the different methods I have. You can also do trial and error, but that's pretty obsolete anymore. So let's go ahead and take a look at the first example. It says factor the following polynomials completely. So I'm looking at my coefficients 4, 5, and 6. They do not have a common factor, so I'm going to go right into it. So I say, okay, I need two numbers that add to give me that middle coefficient, so -5. But when I multiply those numbers, I get the product of my first and last terms. So -24. Then I list all the factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. And if I look, hey, 3 and 8 could give me a 5. So I'm going to put my 3 and 8, my 3 and 8. Now, the 8 needs to be negative since my 5 is negative. So this one, we'll do this one by California method. So California method, you take the first term. I'm going to take the x. I'll do it with the x squared, but you'll see what happens every time. So you take your first term, the whole thing, and you're going to make two fractions. First fraction is over your first number, so 4x squared over 3x. Okay, the second fraction, 4x squared over -8x. So this is why I said you don't really need the x squared, because that squared and that x is going to go away every time. And then you just reduce your fractions. So this fraction reduces to 4x over 3. My second fraction is going to reduce to x over -2. So then these are actually your binomials. So 4x plus 3 times 4x, whoops, not 4x, just x minus 2. Okay, and that's your answer. We're all finished. So that was California method. The one thing you do need to be careful of to use California method, your leading coefficient does need to be positive. So if it's negative, like you're going to see in the next problem, just factor out that negative. All right, so let's take a look at B. What I don't like about B as soon as I see it is it's not in standard form. So I'm going to first rewrite this so that it is in standard form. So I'm going to do -8y squared minus 4y plus 12. And then I notice -8, -4, and 12, they're all divisible by 4. So I'm going to factor out a -4, and I'm left with 2y squared plus 2y minus 3. I'm lying to you about that middle term. I was thinking I only factored out a 2. So minus y, there we go, plus minus 3. All right, so if I were just to make sure, distribute it back together to make sure you get the numerator, or get the previous polynomial, and you do. So you get -8 squared, a minus 4y, and a positive 12. So we're good to go. All right, now that negative out front is just going to hang out with us the whole time. Excuse me. So at this point, we're going to do the same thing. I need two numbers to add to give me my middle coefficient, which in this case is just 1. I need two numbers. When I multiply them together, I get the product of the first and the last. So factors of 6 are 1 and 6, 2 and 3. So 2 and 3 are my numbers. In order for the product to be negative, my first number has to be negative, or my larger number has to, let me start over. In order for my product to be negative, one of the numbers has to be negative. I look at the sum to say, okay, which one is negative? Since my sum is positive, that means my smaller number is negative. So I'm going to do this one factor by grouping. So I have my negative 4 out front, and that's going to stay there. And then on the inside, I write my first term down. I write my last term down. And then these two here become my middle term. So it's a minus 2x, a plus 3x. And the order in which you write those two numbers doesn't matter. Okay, so now I'm going to group them. And like we said yesterday, there always has to be an addition sign in the middle. So now my negative 4 goes along. I can factor out, I'm sorry, I changed these to x's when they should be y's. There we go. So now I can factor out a 2y. I'm left with y minus 1. Over here, I can factor out a 3. I'm left with y minus 1. So check inside your parentheses. Are those the same? Because if not, they should be. So we know we did it right. So I have negative 4. I'm going to factor out what is the same. So that takes care of that and that. And then I'm left with 2y plus 3. I don't necessarily need the large bracket, so I'm going to rewrite it so it looks a little bit cleaner. So negative 4 times y minus 1 times 2y plus 3. Okay, and we're all done with that problem. All right, the last one. Okay, so we're looking at this and we're thinking, oh no. This one has x's and y's. There must be a mistake. There's actually not a mistake. And when you see something that looks like this, so it's ax squared plus bxy plus cy squared. It's actually the same type of problem you had before. So we're going to factor it like the y's aren't there. Okay, so that's what we're going to do. We're going to factor like the y's aren't there. And then we're going to solve like normal, or factor like normal. So I still need to ask myself, well, let's rewrite this. So I'm going to do 6x squared minus x minus 2. And then factor like normal. So I'm going to ask myself, what two numbers added together give me negative 1? But when I multiply them, I get negative 12. So, two numbers that add together to give me negative 1, multiply to give me negative 12. So 1 and 12, 2 and 6, 3 and 4. So 3 and 4 are your numbers. The 4 is going to be negative. So I'm going to factor by grouping. So I get 6x squared plus 3x minus 4x minus 2. Group the first two together, group the last two together, put that plus sign in the middle. So we get 3x outside. On the inside, we get 2x plus 1. Here I'm going to factor out a negative 2, and I get 2x plus 1. So factor out like normal. The common factor is 2x plus 1. And then I'm left with 3x minus 2. Now, we can't forget those y's. So because I had the y's on there, that just means I'm going to change this a little. It's going to be 2x plus 1y times the quantity 3x minus 2y. So you just add the y's to the second term in each binomial. We don't necessarily need that one with the first y, but we'll leave it there for now. All right, so that's C. And really, we have two more examples, but they're all going to be the same. Because in example 2a, we're just factoring by grouping. And in example 2b, we're just factoring using any method you want to. So I'm just going to go ahead and write these down. That way if you want to practice them, you can. So this answer, well, we'll go through and do this one. Looking at it, it has a cube there. So I have 4 terms, and anytime I see 4 terms, the first thing I think of is factoring by grouping. I look at all the terms, there's no common factor, so I group my first 2 together, group my second 2 together, and put the plus sign in the middle. So first 2 terms, I can factor out a 2x squared. So I'm left with x minus 3. Second 2, I have to factor out the negative, and I can pull out a negative 3. So I'm left with x minus 3 again. I have 2x squared minus 3 times x minus 3. Now do look at your terms, double check what we learned yesterday, make sure are any of these perfect square trinomials, or any of them difference of squares, and if not, you're good to go. Alright, and then B, you can try factoring on your own. You should get 3x minus 7 times 2x minus 5. Okay, so you can try that one on your own.